For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. Problem 1. A solid is formed by revolving about the z-axis, the region bounded by the z-axis, the line x equals 0, the line x equals a, and the curve y equals b sin pi x. Find the volume of the solid. You may use the half-angle formulas. Solution to problem 1 using the disk method. The volume is where a, x, is the area of a cross-section disk through x. To integrate, use the half-angle formulas to rewrite. mathhomeworksolver.com. Substituting this in gives. Using the fundamental theorem of calculus, this becomes. Therefore, the total volume of the solid of revolution is. Problem 2. A solid is formed by revolving about the y-axis, the region bounded by the z-axis, the line x equals 0, the line x equals a, and the curve. Find the volume of the solid. It is simplest to use the shell method, but you may use the disk method if you prefer. Solution to problem 2 using the shell method. The volume is where a, x, is the area of the cylinder through x. A, x, equals circumference times height equals 2 pi x, y, x, equals 2 pi x, eb/x minus b, equals 2 pi b, a minus x. Thus, the total volume is. mathhomeworksolver.com. Evaluating, the total volume is. Problem 3. A surface is formed by revolving about the z-axis, the curve. Since the curve is revolved about the z-axis, the radius of each slice is y. Compute the surface area of the surface. Solution to problem 3. The area of the surface of revolution is since the curve is revolved about the z-axis, the radius of each slice is y, r equals y. Thus the area is. The differential element of arc length satisfies the formal Pythagorean theorem. Since the independent variable is x, express dy as. mathhomeworksolver.com. Substituting in gives, taking square roots gives, substituting into the integral gives. To evaluate this integral, substitute, the integral becomes. Evaluating the integral gives, simplifying, this becomes. mathhomeworksolver.com. Problem 4. Sketch the polar curve, r, theta, equals sin theta plus, pi/2, 0 less than or equal to theta less than or equal to pi. Take note, the angle theta varies over only 1/2 of a complete revolution. In particular, label the following on your graph I, in which quadrant or quadrants the curve is contained. 2. The endpoints of the curve. 3. The two slopes of the tangent lines at the endpoints of the curve. 4. And the angle or angles theta at which r, theta, is a maximum. Solution to problem 4. An image file of the polar curve is on the course webpage. The curve is contained in the first and fourth quadrants, where x greater than or equal to 0, but y can be positive or negative. The endpoints of the curve are both the point, 0, 0. The slopes of the tangent lines are both 0, the tangent lines are both just the z-axis. The angles at which r, theta, is maximum are the points where r, theta, is 0. Solving gives. Graphing sine and cosine, or thinking about the unit circle leads to. Thus the equation is. mathhomeworksolver.com. In other words, tan theta equals +1 or -1. Thus theta is 45 degrees or 135 degrees, i.e. mathhomeworksolver.com.